Hi apes, this is your screencast part 1 about oil and natural gas. Okay, so oil and natural gas are just hydrocarbons, so molecules made up of hydrogen and carbon atoms. Natural gas has 4 or less, oil has 5 or more. That just says whether it's in a gaseous form or in a liquid form. Oil and gas are usually found together. Gas floats above the oil, and then usually there's usually some groundwater found in there as well. So there are a lot of environmental impacts of oil and natural gas in the process of combustion, production, and transport. The biggest thing with transport are the spills. In combustion, it's all about the increase in carbon dioxide and all of the different emissions. Okay, so oil is petroleum, a naturally occurring flammable liquid found in rock formations in the earth. It's distilled into gas, diesel, jet fuel, kerosene. Okay? We're projected to have an 80% depletion time to have about 50 to 100 years of oil left. Those numbers will go up with new extraction technologies for ultra deep water drilling, etc. Saudi Arabia has the most oil and it could supply the entire world for about 10 years. Alaska's North Slope has some oil, and then ANWR, the Arctic National Wildlife Refuge, would meet world demand for 1 to 5 months. Okay. So ANWR is something that has been thrown into the news, out of the news, and it stands for Arctic National Wildlife Refuge. And right here, you see ANWR. We have already a National Petroleum Reserve in Alaska, and then Prudhoe Bay is where there's lots of drilling that's going on. And then there's the Trans-Alaska Pipeline that comes down to Valdez, and then the oil goes on the boats, and the boats take it out. So they want to drill in ANWR, and environmentalists always block it and say, we don't even know if there's oil there. Okay. Oil is refined by boiling temperature. So you take a bunch of oil and you boil it, and at different temperatures, your petrochemicals, which are the products of oil distillation, actually come out. So if you look at this picture, your furnace is here, your crude oil heats up. First, you get gasoline at the lowest boiling point, then aviation fuel, heating oil, diesel oil, naphtha, grease and wax, and then basically what's left over is asphalt. Okay. You boil the hell out of the oil and make it into all different sorts of things. So we have proven oil reserves and unproven oil reserves, and these change depending on our technology of extraction. So proven, we know how to extract it profitably with our current technology. Unproven is, okay, we have a chance that we can recover it in the future. We think it's there, but it's not 100%. Okay, peak production is you're at the top of the curve, and after that, you're starting to get less and less oil out, and that's when you have to realize, okay, when is it going to be stop being profitable? World oil consumption has increased, and it will continue increasing. And then OPEC is Organization of Petroleum Exporting Countries. I'm sure you've heard that acronym before. It's 13 countries: Algeria, Angola, Ecuador, Indonesia, Iran, Iraq, Kuwait, Libya, Nigeria, Qatar, Saudi Arabia, the United Arab Emirates, and Venezuela. Okay? It is just these 13 countries. They have most of the world's crude oil reserves, and Saudi Arabia has the largest amount of it. Okay? The US and China are the largest users of oil, and we're very dependent on OPEC for that oil. Okay? Oil and gas reserves, you can see here, Russia, Saudi Arabia, and the US, the Gulf of Mexico, Southern South America, part of Canada, and even Northern Africa and Australia. Okay. So North American reserves, we kind of have them all over the place, but it's that whole extraction issues. Okay, so natural gas. Natural gas is mostly methane, but it's also a mix of butane, propane, ethane, and other things like that. Burning natural gas is the cleanest burning of the fossil fuels. It produces carbon dioxide and water and energy. We can store it in pressurized tanks as liquid, but again, what that is that's an extra step then. We have to pressurize it and liquefy it, which decreases the energy efficiency. Russia and Iran have a lot of natural gas, and it's a versatile and clean burning fuel, but it still releases carbon dioxide. But as far as the three fossil fuels, this is the best one for the environment. Sometimes extraction is a little tricky. Okay, so natural gas usually occurs in the same areas of as oil. So if you see on this left-hand side here, here's an oil rig, and it's not on fire. But what's going on is this is an oil rig. It's not a natural gas rig. So the natural gas that is coming up with the oil, this oil rig is not equipped to also capture that natural gas. So what they do with that natural gas is they actually just burn it off. Okay. Methane has more of an impact on the atmosphere than carbon dioxide. So releasing the methane, the natural gas, into the atmosphere is more harmful than actually burning it, which makes no sense, but it's actually true. Okay. Storage and transport is a major problem with natural gas because when it's in its gaseous form, it takes up a large volume, and to liquefy it, it takes a lot of pressure and energy to actually liquefy it. Okay. Natural gas is difficult to store and ship. Most of it is burnt at the well. It sucks. So here you go. Advantages and disadvantages of natural gas. This is also on your notes. I'm not going to waste your time with that. Okay. Environmental issues with drilling is associated with a huge amount of issues. You have groundwater contamination, destruction of the overlying land, pollution from oil spills like we saw with the Deepwater Horizon blowout and the Valdez oil spill up in Alaska, which we're going to go over later. And we have this new crazy stuff called hydraulic fracturing. Okay, so natural gas. Liquefied natural gas and liquefied propane gas. So liquefied propane gas is used in rural areas. If you have a gas grill and you get propane for it, and you take your propane tank and you shake it a little bit, there's actually liquid propane in there. It's in its liquid form instead of being gas. So and anytime that you liquefy a gas into a liquid, it takes a lot of energy. So then it makes your natural gas have a much lower energy yield. Okay. The US only has about 3.4% of the natural gas, but we use about 24% of the world's annual gas, which is a lot. Then we have unconventional natural gas. We have coal bed methane gas. So in coal beds near the Earth's surface, what you have is you have this methane gas sitting on top of it. There are huge environmental impacts of extraction of this. Methane hydrates are kind of like these ice crystal-y things that are trapped in icy water and in permafrost environments on the ocean floor, and we really just don't have the technology to extract these. Okay. This is a picture of the methane hydrates, and you can burn it. It's almost like a coal, but with methane. Like think of dry ice. Okay. Crude oil. I don't know. This is a weird position of this, but crude oil is your petroleum, and your natural gas and your crude oil are found together, and it's plants and animals under these high temperatures and pressures over millions of years, like we talked about today in class, that forms the coal, also forms the crude oil. Okay, so for oil extraction, they're usually found through echolocation, looking with these sound waves into the layers of rocks. Then you drill down into this oil reservoir. Because the oil is under immense pressure, it will shoot up to the surface by itself, which is why we had such a hard time capping the Deepwater Horizon oil spill. Once that pressure is no longer really great and the oil isn't just spurting up, a lot of times what companies will do is pump water or gas into the reservoir to push the rest of that oil up, because oil is less buoyant than water and it's actually going to float on the top. Okay. Here you go. The drilling rig, it's anchored into the seabed. Okay. And then we have oil recovery. So you have primary oil recovery, that's the gravity, it spurts out. Secondary oil recovery is you're injecting something else in to get in whatever else is out there. And then tertiary oil recovery is you're literally trying to scrape the bottom of the barrel to get everything out. But the average yield of a well is only 30 to 50% of what's actually in there, because once you go beyond that, a lot of times it's too expensive to extract more. Okay, Don't forget to study for your vocab quiz as well tomorrow, and I will see you tomorrow.